Comparison with and without, right?
Yes, and again, man, I don't even know if his product's in here. It's such a concern of mine.
Right.
And it's going to be completely blind. There might not be any difference. This machine might outperform it, but we're going to run a straightforward comparison on this program right here. What it's going to do is coming all the way around. We'll be profiling it outside, taking the dimension. And this guy here, we're cutting 3 slots. We'll be able to check the chips, the color of the chips, the slot thicknesses. And then we're going to go down and drill a series of holes. And we'll be able to compare the chips, the size of the hole, and the location of the hole.
Okay. Are these the chips you're getting now, as is?
That's aluminum, yeah.
With aluminum, okay. And then we're going into steel?
Yeah, this will be 1018 steel.
1018 steel.
Both brand new tools. Got a brand new 10 millimeter carbide drill, brand new 1/2 inch Promax, or these are hot mills, brand new hot mills. So they're identical tools going into it.
Okay.
Same program, same speed, with and without.
What's the cost of that tool?
That drill is $112.
$112 for that drill.
Yeah.
You're going to use how many a shift on that? A steel job running 200 pieces.
One.
Gonna go through one.
In an application,
You got to
like
sharpen it or toss it. Will it pop?
If that one pops, it's going to snap that drill. There's no giving carbide. It doesn't flex. It doesn't. And what I'm doing is I'm going into a dangerous operation. We're 1.5 inches thick here. This drill's meant to go 2.5 times the diameter. So it's a 0.4 drill. Theoretically, I should only be going down 1.2. I'm going down 1.5. So we're already pushing the drill.
Okay.
We're pushing the end mill. The end mill's going to be at its higher end feed. And typically, I would use 2 tools, 2 end mills, a rougher, then a finisher. We're going to use the rougher and the finisher. The rougher's going to do the finishing. So we'll be able to compare sizes of the slots, sizes of the cube, hole location, and hole size.
Okay.
Good luck to Jim.
Right.
We're going to see right now what it does. I don't even know.
Okay. You're using 2 different machines. What are the differences in the machines that may cause a play in that? All the speeds the same.
Speeds and feeds are the same. We got more of a rigid spindle over here.
More of a rigid?
Yeah, that spindle itself, if you were to look at the bottom of that spindle right here, let me show you. See that? That's the diameter of that spindle all the way up.
All the way up, okay.
Okay, and the motor is right here. The motor is this big.
So you're going to get more pressure on that.
There's more low-end torque on here.
Right.
But you won't see that in the machine, in anything you're doing. So you got your motor, it's an integrated spindle right here, and you look up on top there, that's the motor on the top. It's a cartridge spindle. The speeds and feeds will be the same. This has got more low-end torque. It's just, this is an F250, that's an F150, okay?
Shouldn't make that big of a difference.
No, and what he's doing right here for a test will make 0 difference.
Right.
If you want to start pushing slotting cutters that are this big, it makes a huge difference.
Okay.
You know, actually, that guy would not run.
Would not, correct, exactly.
He's got to go in there.
Yeah.
And I'll bury that thing right out. I'll bury him in right here, full depth of cut. He would stall this machine out.
Yeah.
Or what I got to do is I got to get my RPMs up so high to a fracturing point where you're going to ruin your insert.
Right.
That's where you'll pick it up.
Yeah.
But he's just getting that set up.